Welcome to The Math Show with Mr. DeClerico. Zero is a symbol that means nothing, which is actually revolutionary. Zero's relevance gradually trickled into human history. In ancient India, it was used in finance to mean that you had no debt. The Mayans, on the other hand, were among several cultures who used zero to indicate an empty place value. And the reason I highlight the Mayans is because I'm especially fond of their symbol for zero, this little shell thing. To see it in action, here's how we'd write 2012 in Mayan script. As avid astronomers, big numbers that really stack the place values come with the territory, even with their famous base 20 number system. But perhaps the most fascinating thing about zero is its plethora of properties, which began to be canonized by the Indian mathematician Brahmagupta and developed over time. Let's talk about some properties of zero you might see in your math class and explain why they make sense, because sometimes it's not so obvious. Adding with zero is, well, straightforward. So is subtracting. Multiplying by zero is easy too, and as an added bonus, it makes for a hilarious rage quit in algebra. But dividing by zero is illegal, don't do it! But why? Well, what is division? The most basic interpretation is that division computes the number of times a divisor is contained within a dividend. For example, the dividend 12 contains 6 2's, so we'd say 12 divided by 2 is 6. So if I had 1 foot of bread, for example, and cut it into slices of size 2 inches, I would have 6 slices. But how many zeros does 12 contain? Like a lot? Infinity? How much of nothing does something contain? When one tries to divide by zero, is anything actually being divided? It's like trying to cut a loaf of bread by not cutting it. It feels so unproductive. What am I even doing? What does it all mean? As you can see, dividing by zero opens up such a big can of worms that mathematicians are like, nah bro, let's not. So just listen to your teacher. Don't do it. So what if zero is an exponent? You may have heard that anything to the power of zero is 1, but that's not necessarily true in all cases. 0 to the 0 is sometimes defined as 1 and sometimes understood as something called an indeterminate form. More on that later. So why is almost anything to the power of 0 equal to 1? To keep things from getting awkward, let's assume that a and b, two values, are not equal to 0. Then a to the b divided by a to the b equals 1, because of course it is. But a to the b divided by a to the b is also equal to a to the b minus b. Power divided by power, subtract the exponents, which leaves us with a to the 0. So by the transitive property of equality, a to the 0 equals 1. Now let's talk about this guy. Folks who don't know math think it's this, but folks who do know it's this. Why is that? Well, what does that exclamation point mean? That's called factorial. We see it a lot in probability and counting, though it makes some fascinating appearances late in calculus as well. At the base level, it means take a positive integer and multiply it by all the positive integers below it until you're down to 1. Here's an example of 5 factorial. So how do you do that with 0? Well, here's a generalized rule for the factorial for a positive integer. If we acknowledge that this is algebraically equivalent, we can extend the definition of a factorial to include a value for 0 factorial. Substituting 1 for n, we get this. There you are, 0 factorial. Since there are no positive integers below 1, 1 factorial equals 1, so that means 0 factorial would evaluate to 1 as well. One of the most important properties in algebra is the zero product property. It states that if a times b equals 0, then either a is 0 or b is 0, or technically both could be 0. The point is that at least one of the two factors has to be 0. This principle is massively helpful in solving polynomial equations efficiently if you're good at factoring. For example, if I'm solving this polynomial equation, if I can just get 0 on one side and a product on the other via factoring, I can set each of the factors equal to 0 to get my solutions. Big note here, this only works when I get 0 on one side. It's the zero product property, for goodness sakes. To demonstrate how important this is, let's do this problem the wrong way. If we just leave the -2 on the right-hand side and factor the left, supposing there's such a thing as a -2 product property, we get an incorrect set of solutions. And finally, the one that you've been waiting for. What on earth is an indeterminate form, and what does 0 have to do with it? Well, possibly the most famous indeterminate form is 0 divided by 0, which Brahmagupta supposed was equal to 1, and he was wrong. But sort of right, it's complicated. This demands an explanation. Let's say we divide 0 by 0 and it's illegal, don't do it! I know, just let me try this. Let's say we divide 0 by 0 with the old division algorithm and just see what happens. We could suppose 0 divides 0 one time, and the remainder checks out. But we could do the same supposing 2 is the answer, and 3, and anything you'd like, even 0. So what's the answer? That's just it. 0 over 0 has no strict definition. That's what makes it an indeterminate form. It's an entity whose value cannot be determined. Thanks for watching The Math Show with Mr. DeClerico. Be sure to click subscribe, hit the like button, and all that good stuff.